Hello, this is Zachary from Zachary 3D Prints, bringing you how to review news and other cool things you can do with 3D printing. If you're new to this channel and not subscribed yet, please consider subscribing. And hit the notification button to get the latest news and updates right on your mailbox. So, for this Friday evening, we are going to hang out a little bit, and I just see that I have one viewer. I don't know if it is me or if it is somebody else. Feel free to write something in the chat box, then I know that I'm not talking to myself. So, and as you can see, this is my first live stream. It's now a 21.07, and yeah, I had some difficult times setting up Streamlabs OBS. It is my first time and I was still struggling with the handling of my Zachary PS Gaming Twitch live stream. I also do some gameplay on my PlayStation 4. It's the PlayStation 4 Pro. And there are some games that I also like to play when I'm not doing any 3D printing. Well, at this moment, the two 3D or three 3D printers are currently not working. My two daughters, 6 and 8 years old, they are watching a girls movie with dancing. So, well, so in the meantime, before I'm going to continue, I'm going to do some other setups for this live stream so that I know for the next time that everything is running nice and smoothly. I have to remind myself to watch in that camera. I can also switch to a different kind of camera, but that I will leave for a other time. It's my first time that I am going to do a live stream on Zachary 3D Prints, and I will leave that also on the YouTube channel, so for everybody else to watch. I also did for the EasyTreet X1 3D printer, I did a live stream, but nobody showed up, and I had also some difficult time with the connections, with the camera, with the audio. Not everything was set up right, and also I was a little bit late. So, well, now I'm using Streamlabs OBS, and that works much better if you have the right settings selected. If the audio is alright, then leave it in the chat. I have two goals for this live stream today. One is for just hanging out and talk a little bit and chatting, and the other part for this live stream is also start designing my own 3D printer. And I can spend a whole evening designing without any talking, no problem, but I can also do both together. something here. Hello. Everyone. So I had something in the in the chat box. So when you just turn on the live stream, my name is Zachary from Zachary 3D Prints. If you didn't know me already, I am the content creator on Zachary 3D Prints. I also create every Wednesday new videos about how to review news and other things. And on the Friday, I already mentioned it, I do some news and updates. Most of the time it are closer looks on new printers that are going to hit the market. So I always wanted to design my own 3D printer, and well, it shouldn't be that hard when you're using TinkerCAD. There are also some other CAD designing software like Fusion 360 and also Google SketchUp. I don't know if somebody is using that program as well. I had some experience with Google SketchUp, but most of the time it are just squares and some little lines and nothing in particular. So my MacBook Pro is blowing a lot of air out because I'm doing live streaming and I'm also using a lot of CPU power. Well, I think that is kind of okay. Let's see what we have here. Usually I have some graphs, but they don't show up now at this moment. I put one there. Oh, my CPU is at 19%, so that is nice. Well, everything looks nice. In the meantime, I'm going to start TinkerCAD and I'm going to start designing. If anybody wants to join me in the chat session, just feel free to add something in the comments. Let's see. We're going to the dashboard of TinkerCAD. The idea behind designing my own 3D printer, well, I like to make things as well. Well, if you look to my TinkerCAD, I did already do a lot of things. Some samples, some test outs, tryouts. Also the Prusa i3 MK2 power supply remake. I don't know if you did watch that video, but it's worth watching. Also the anagram of my logo, C3DP. Also some other thing that I downloaded to try it out. Well, my idea is to make a 3D printer. I don't know if you did watch the description of the live stream. I'm just going to go in Thinker this. Well, this is the idea behind the 3D printer that I want to design myself. It's a little knockoff of the Prusa Mini, but I want to design everything from scratch. just some little basics. I'm going to start with designing a bracket for the stepper motor. I also need to get some other ideas to start making it. Hello, Mike C, how are you doing? Welcome on the live stream. It's nice to have you here. Yeah. So yeah, basic idea of this 3D printer is that I'm going to design it all by myself. Some little other ideas, maybe you can also mention something about this. And the idea, oh, that's a good one. I need to switch over. Of course I need to switch over. And display capture. Whoop. Oh, very nice. Thank you. Thanks for asking. That's going pretty well. So, like I mentioned, I didn't show anything at all. Nice that Mike C did mention it. I don't know, where are you at this moment? Are you at home? Are you in the car? Where are you watching this YouTube video? So let's go and start with designing the bracket for one stepper motor. Well, I do have a face cam. I can add one if I can do that. So if I do like this, and then, oh, this is not working. This is not working, no. Oh, you're watching from your parents' house. Well, greet them. How do I add? Oh, wait, that's a good one. That I can do. Yes. I've got an idea here. I'm going to add a second camera. A video capture device. Yes. And that one is going to be up. Have a little patience. I'm just still setting everything up here. Now I'm going to do that. Or I can use that one as well. Like that. I'm just adding this. Is this okay? Is this better like that? I don't have a stream box at this moment. I did download an app for my Twitch stream, try to use it, but I still need to work out how live streaming actually works out that well. I also have something like a studio. I think the image looks way better now. Does it? Little small. Okay, wait. Is this better? There's a little delay, I understand. Nice, great. I didn't watch it full screen, and it was already huge. I'm sorry. So, I'm going to exit this part here. Oh yeah. And I'm going to design a new part. Brand new. But I'm wondering if should I start with designing everything piece by piece, or should I design the whole thing? At the other end, it's easier to start using only one part at a time. So let's start with a cube and a ruler, of course, or else we don't have any measurements at that moment. Like that. And of course I don't have any stepper motor here, so that is very handy. Well, yeah, I got a this is not working very well. So we are going to Google. Of course, I mistyped. Ah, that's nice. Something like that. And the holes are M3 size. Okay. Okay, nice. So 4.3. How do I want to have this? This is the size of a stepper motor, and the height, how high is the stepper motor? L. Does it say anything? $40. Okay, they take 40. 40. So this is the size for a regular stepper motor that we are going to use in the future. So I'm going to make a hole out of it, and we are going to make a bracket. The grid we are going to adapt to 0.5 millimeters, and we are going to mount something over it so that we have something for the z-axis, because there I want to start at first. My daughters are having fun, they are laughing. So if you are using TinkerCAD, when you are going to flip models or flipping shapes, when you are twisting and you take it on the inside, it goes like this: 22.5 degrees, 45 degrees, 67.5 degrees, or 90 degrees. If you're going outwards, you have more precise. So if you ever want to use that, then you know now. So I also took a caliper when I'm going to make some sides, then I know how thick the walls are going to be as a realistic reference. So we are going to put this on top of it. It's very high now, I know. Something like this. I'm going to change it a little bit because I don't like the idea that I'm working on top of the So we are going to make a wall thickness of 5 millimeters. 5 millimeters would be like something like this thick. What is that? Yeah. Natuurlijk mag dat. So when I do 5 millimeters, is something like this big. So I want to add some screw holes also there, and I also need to have a opening for the motor axis. Wat was dat? So first I'm going to take the middle whole section where the axle from the stepper motor is. It's what I mean is this part. That part is 22 millimeters. I don't need to have the shaft of the axis because that's not so important. Also here I've got a very good view over a NEMA 17 motor. So it's 42.3 maximum. I can enclose this motor fully, but then also the heat of the stepper motor cannot vaporize, cannot cool, so I have to be careful for that. Hey, hello buddy, how are you? So we are going to take some measurements. Well, one of the measurements is the part where the stepper motor is going through the mounting hole. So we take a cylinder. The size is 22.3. No, 22. Well, for the safety, I take 23 as a number, and also here 23. You can hear me pretty well. So, well, this doesn't have to be that big. Like I mentioned, I'm going to make this 5 millimeters. I think that's pretty okay. So, well, we're going to select both, and then we take the alignment tool. Very nice, thank you. So, also there, it's right in the middle. It does look okay like this all the way through. Let's make it into one part. Ta-da! That's the first part that I'm going to do. Thank you. Sometimes I have to look down for watching the chat stream, so I hope you don't mind. Now we take the screw holes for mounting the stepper motor. The stepper motor has M3 nuts, screws in it, and they are 4.5 millimeters. Okay, and they are 31 away from each other. Okay, we can, what I like to do in this kind of stage, I'm going to test print it. When it fits, and if it doesn't fit, of course, then I just scrap the part and make some adjustments until it fits. So now we are going to make the first screw hole. Measurements 4.5, just like make it a little bit bigger. I think 5, and we take as height 6. We put this on the side, and we are going to take this part into here because I want to have accurate measurements. I do have the snip grid on 0.5 millimeters. Of course, there are many other, maybe better ways, but we'll just try out how this is going to work. I don't have a measurement how far that it is from the side, but let's take the 31 as a reference. So we take this one, Control C, Control V, of course, the wrong one. Oop. Now here we're going to use midpoint. .5. Okay. So I'm going to make it as a group, and then Control C, Control V, and I'm going to place them on the other side. And there I use also the midpoint function, 31.5. And that we also make into a group. Now, once we have made that into a group, let's group them together. So Control Shift and then align it there. I think it's looking quite nice like this. I have to make more stepper motor mounting brackets. So before I'm going to adapt this more and more, let's make a copy of it and move it away from the building plate. If some things go wrong, we can always fall back into that part that we put on the side. So this square represents a stepper motor that I designed based on the measurements. Well, it's just the box because I don't have a stepper motor right here that I can take the measurements. I use some Google references. I don't know how precise that is, but I've got some measurements which I can use. So I think it looks quite nice like this, and let's see if we can make some brackets. Are we going to make brackets like this? Just a second. We are going to lift it up like that. Now select that one, align it here. Oh. $43. Something like that. Looks okay. And I don't like the red color, so change it into gray. Too dark. That is better. So I am wondering how I want to have this Z-axis stepper motor attached to the design of the 3D printer. Well, I'm going to make this bigger, and this box is 43. Let's make this 53 and 53. Let's move it a little bit higher. Oh. I want to have the stepper motor as accessible as possible and not too much enclosed. Let's see what we can do with the roof. We have some other triangle shapes that works much better. No, I use this. Like that. We are going to make it into a 43. Yeah, I always hit my keyboard pretty hard. No, this was 53. 53. We make it into a whole shape, and if we press shift and we move it, then it is working out like that. Do I want it? No, I don't want it. I want it like that. Control Z. see what happens if we do it like this. This we make it. I see that it's not touching. Oh, it's not using midpoint. Okay, wait. Let's change it here. This endpoint 0. Whoop. And then we align those two. Thanks for the following on Twitter. Align it here. Oh. No. Do I like it like this? I can do it a little bit higher. Yeah, I want to make it a little bit higher so that I have my 5 millimeters over there. Thank you. Oh, no. Don't want to select everything. That 53. Thank you. So we are going to line it. Oh, wrong one. I need to have that one. I'll line it here. And let's make it into one shape. And let's see what happens. I think that looks quite nice. And let's move this over to here. But then it's too big, so I have to make a little adjustment. How tall is this? This is 40, so well, let's make it also 40 then, shall we? Yeah, something like that. Now we are going to move it here. And we are going to align everything. First I'm going to use the gap cube. I don't know how you call it. Something like that. Do I want it right in the middle? I think it's looking quite okay, or just not. I think I'm going to make a little adjustment here. Just a little bit to the back. So it's right on that edge. Oh, 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 oh. 1, 2 times back. We take the black middle point. Do you also use TinkerCAD, or do you use a other different kind of CAD software? And what are the applications you are using it for? I think this looks much better. I think also the stepper motor has a lot of support. And eventually I want to make this an aluminium extrusion next to it, so a mounting point. So I also need to make some screws over there. Well, for the basic idea. And you know, we can make many adjustments as we like. So we are going to select both. Oh, that one and that one. There you go. It's looking nice. Well, I also need to have an extrusion that I can put next to it, so that when I'm going to make some screw holes, that they are also aligned with the extrusion. Well, I'm going to make a new, I'm going to duplicate this, something like that. And then we go back and we are going to look if we have a extrusion on TinkerCAD. Gallery. And where? Aluminum extrusion. Sometimes I need to think about the correct English word. If I've done it correctly, I should have some results. This is in 2020, I need to 4040. It's also handy when people are already designed some V-nuts. Show more designs. Clip. Well, this is in 2040, but it will do the job. Copy? I'm not going to tinker it. I'm just going to copy it to have my size right. So Control C, and now we are going to use it here. Control V. So, and we are going to flip it 90 degrees. We are going to lift it up 0, and we are going to move it around. Look at that. That looks awesome, right? I love it when a plan comes together. So to get the screw holes at the right place, I'm thinking about it to just take one, and we are going to I think the size was 3.5, but I don't think it is a problem if we are going to, or shall we do it, shall we not do it? Oh well, make it just 4 and 4. Is this the correct size for an M4 nut? We are going to take the caliper. We're just going to try something out here. Good that I took a measurement, 4.3. And there needs to be an M5 in it. And as I can remember, I saw also something here. No, this is my dashboard. I don't want my dashboard. Hey, hello Steve, buddy. How are you? Thanks for joining the live stream. Just pressing there, search for designs. Oh, I do need to type it again. Extrusion and 2040, something like that. I also did see a M5 nut, I guess. M5, come on. No, I leave one little thing away from this to get the right. I always smash the enter button. M5. Then we take Google. Sure means M5. Screw. Something like that. M5. I don't want an inch. Shall we take 5 millimeters? Oh, wait. I've got something here. Let's see. I have some measurements here. M5. 6. 5. Yeah, is the width 5? Oh my gosh. Okay. So 5 and 5. Let's do it like that. And the size of the thickness from the bracket is 5 millimeters, but I will take 6. In the meantime, we can make it countersunk. Oh, no. Wait, I'm going to enlarge it, and then going to flip it. Okay, looks nice, like this. But I think the hole would be too thick. Let's make it 4. And this also 4. If it is not correct, I can always use the drill, or I can always change it into TinkerCAD. So, Ctrl C and Ctrl V. Now we are going to move it up just a little bit. This is just eyeballing. Oh, wait. Oh, no. Okay. We take those two together. We align them. Something like that. Oh, no, not that. Well, let's group it together. And let's see how far it is. Let's see. That one is right, and it looks quite good in the middle. I do see that those two are not aligned together. Those two are not together. Let's make that 40. Hey Polymate 3D, hello, welcome to the channel. body. So we are going to make this into 6 millimeters, and then we are going to make there Ctrl C, Ctrl V. We are taking the extrusion away for just a second, and we are going to align these holes right where they should be. First we're going to align them together. Shall we take 33? Just align them together. I was pressing the wrong button. No, didn't take. That. I'm also going to put the ruler into midpoint so that we can align pretty well. Let's take 33, spaced equally. I don't see that I did space that one equally, so 33. Okay, 25. I should not touch that part because I already measured it to this here. So it's nearly in the middle, so I want to keep it as good as possible. Oh. I did make a little error, which I'm going to one back. I'm going to remove this part. Yes, with that I'm going to use midpoint right here. Use midpoint. Then I'm going to copy it and paste it, and then I'm going to move it over there, and I'm going to use the distance of 33 I said, like that. I will group it together. I thought they were all gone, and just put it in there. Oh, it's a little bit off here. Well, we shall ungroup it then, and then use the alignment tool. No. This is not going well. Let's do it again. next one. Ungroup. Then we are going to align it there. Group it. And then Ctrl C, Ctrl V. Group them together. Make sure that midpoint is selected. Three. And we are grouping them together. And there. They are still not okay. Come on. Come on. Ungroup. Align. And here. Group together. Yeah, it was a little bit tricky here. So, I hope that's not okay. I had to think about it, not to align it in the z-axis, if I say correctly, because now I have the right measurements. Well, measurements, eyeballing measurements. Whoop. Pretty much okay. I think that will do the job. Thank you. So we are putting the example extrusion away, and now we are going to make it into a hole. It is a group. I put it on 6 mm so that I can look through, but I can't, so I make it a little bit wider to make sure that I can look through the holes. Yeah, that's all the way through. That is nice. I'm going to select the other part and I'm making sure that it is aligned in the middle. Here it is in the middle, so that is nice. And then we group it as one part. And now we have the bracket for our Z-axis stepper motor. There was a little issue here. When I'm looking correctly, I just saw a little gap between the two parts. So now we are going to group them together. And then you see exactly what I mean. So I'm going to ungroup it, make this one a little bit bigger, 5.1. Then I'm going to select this one, and still not. No. Oh. It's wider. Oh well, doesn't really matter. It looks okay. Looks nice. So when I'm going to put the extrusion here, I can also extend it. Also looking for the control box that I'm also going to add in a later stage. Maybe I'm going to do that today. Something like this. Yeah, I'm going to copy this extrusion. Ctrl C. Hey. Ctrl C. Ctrl V. And as you can see, TinkerCAD is still taking midpoints instead of the points that I normally would take. So I'm going to change this to endpoint, so I am able to put this on 0. And then move. No. So Ctrl Z, I'm going back. What is selected? Oh, there it is. 0. There you have it. Nice. Now I'm going to attach it, something like this here. And if I'm going to turn this stepper motor bracket, I think my measurement is a little bit off. Or not. We shall see. Shall we try? Shall we try? Are we going to do that? A bit higher. Oh, it was not all the way. Oh. Somewhere it just skipped and it was not right. So I need to see where I did flip it and it was not standing correctly. Yeah, it's yeah, it was also off. And we don't need to have the full measurements. No, up, come on. Yes, yes, that is what I want. Zero. And then we are going to turn it 90 degrees, and we are going to do it right here. It's not all the way attached to it, something like that. And now we are going to take the bracket. We are going to twist it and let's see how far we came in matter of the mounting holes. Oh, no, I need that one. Now we're going to put it up. Doesn't seem that great. I can flip this around like that, then it will fit, something like that. What shall I do with this? That is also possible. I'm going to make a am I going to do that? Yes, I'm going to do that. I'm going to delete this and I'm going to make some no, I'm not going to do that. Well, usually for the z-axis, the the stepper motor bracket is attached to the z-axis. Yeah. Did I took a wider measurement? Yes, I did. I did. So I'm going to select that one and group there and group another time. Then I take those and I see that they are they? Yes, they are. Okay. So I'm making sure that I have selected here midpoint. Did I have midpoint? No, I don't have midpoint. Use mid. No, I have midpoint. Yes. So the distance between those. No, that's not midpoint. This is midpoint. See? Come on. Do I have midpoints or don't I have midpoints? Oh no, they are grouped together. That's why I yeah, it does use midpoint, but at the other hand, it doesn't look like I'm using midpoint. Well, we take the caliper and we are going to take this measurement. Okay, 26. Because it's measuring from endpoint to endpoint. Or do I not see that correctly? So I'm putting here in 26. And also this measurement 26. We are going to group them together. Ta-da! And now something like that. But I have to do it like that I can mount the bracket next to the exactly in the middle. Just going to do that if you don't mind. See that not everything is grouped together. Now together. I like the gray color. Let's make it gray again. And here, let's also group that. So, if I now put the bracket next to it, it should align way better. Yes. Yeah, the measurements. Yeah. And if I flip it, it should also look similar. Yeah. And this does look okay like this, but only I've got a too big hole here, so I need to do something about that, or I am going to do something totally different. I'm going to flip this on the other side, something like that. And I'm going to make a control box for the main controller. I don't know which kind of controller mainboard I am going to use, but I was thinking about it to make a controller box with some kind of drawer that you can put different kind of mainboards in it. I don't know, what do you think about that kind of idea? L-shaped piece. Which kind of piece do you mean? Polymate? Polymate? Those extrusions I took from an example from TinkerCAD itself. The frame is going to be made out of aluminum extrusions. So I'm going to see how far this design is going to be. It's going to look like the Prusa Mini, but then a little bit different in design. And well, I'm tinkering a lot. I'm designing this myself. So if I'm going to make a controller box, I want to be able to put a drawer in it where I can put my mainboard in it. So I am going to see how much possible that is. Yeah, that's completely right. I'm just trying to figure it out that I can mount it to or the extrusion from the y-axis, or maybe that I have the possibility to attach it to the z-axis and the z-axis attached to the y-axis extrusion. I always say aluminum profiles, but everybody will understand a little bit what I mean. But let's make the controller box. So we put this a little bit on the side, something like there. I'm going to check the controller box. So how big are controller mainboards? How big are they generally? Yeah. Um, 90. Well, I've got a spare control board laying around from Reality. Any burnt Fryt big tree tag. I'm going to take those two and see how big they are. Just a moment. So I got three main boards actually. I've got the famous Lllet'st A8 Melcy board. I got a stock Ender 3 controller board, also Melcy board I guess. And I got a big tree tag Fryt SKR Mini E3 1.2. As you can see, I fried the Y-axis stepper motor, so I'm not going to use it in my project, but I can take some measurements because eventually I really would like to design everything from scratch within a 3D printer. And yeah, well, I need to learn somewhere, you know? So, well, let's take some measurements from a standard board, because this one I have spare, which I can use. I also got a spare screen, but eventually I do like the boards from Big Tree Tech quite a lot. They are easy, they have a lot of possibilities on it, and as long as you don't fry them, they can work pretty awesome. And they are open. So, well, let's take some standard measurements. This board is 770 by 100. Well, if I'm going to get some very close onto the board itself, then I've got a very tight space. But it is also nice to have some airflow within your controller board. Well, we can make a very large box, you know, but the basic idea is to make a drawer kind of idea. So let's make a controller board lookalike. Well, my Reality board is 100 by 70, and for the size we take, well, what's the highest point we have on this big Tree Tech board? Yeah. 21, 22, let's take 22. We take 22, something like that. So I need to make a drawer there that I can put on there. So we put this on the side, and we are going to add the drawer. So the first measurement, the width of this board is 70. So let's make 100 of it. No, wrong side. 100. To make a distinction between the slide, the bracket where the motherboard is going on, let's make it into a... Shall we go for pink? Yeah, well, let's do that. What are your thoughts about the big Big Q B1 3D printer with the pink metal parts. Let's make this into wow. It was a little machine. I got also a little machine and it is not working. You can guess which kind of 3D printer that is. I got only 3, so 3 times is a charm. 5. So this is the height of the, well, that's kind of okay, I guess. 5 millimeters. Let's take it into the real world. 5 millimeters. Look like this big. Yeah. So let's turn it around because we are working everywhere. So that we're going to put it on the floor. Like that. Oh yeah, me too. My first 3D printer, I don't know if you are subscribed to my channel or not, but my first 3D printer was the CTC Prusa i3 MK2 3D printer. And my latest videos are a conversion to a more realistic MK2 3D printer, the Prusa i3 MK2 3D printer. I don't know that one yet. I'm in 3D printing for 2.5 years, 3 years, something like that. So a lot of things are pretty new still. I need to learn quite a lot as I go. So first measurement was 70. I calculated 15 on each side to put the board there. So if I put the board right on top, this is the space that I have. And I want to have a good airflow around the sides of my main board. But I also want to have the ability to modify or upgrade the board, and I am not attached to the size of the board itself. Oh, thank you. So I'm going to, so this size was 100, so that is the width of the board that I'm going to use, and the length was 100, and I'll add 30 with it, so 130. So I'm going to change this into endpoints. We are not working with squares at this moment. Zero. Now, come. So, and when I take my example motherboard, my control board, I align it something like that, So I've got enough space around my main board to have a nice airflow. So I'm going to take that away because the 22 millimeters, that is the height of a possible controller board. So when we are going to slide it out, I am also thinking about it when I'm going to do that I also need to have longer wires. So in the first place, I think a drawer would be very handy, but when we are going to use wires, we have a lot of excess wires, so maybe not using a drawer after all. Okay, so we are going to need some airflow here. Or shall we put that on the sides, because we also need to have some screw holes to mount the controller board onto the plate. Well, let's extend this one. Let's see how high this is. 45. Yeah. Can we also make it 45? Something like that. Yeah. I think it looks quite nice like that. Now we are going to take a box, we enlarge it, no, I need to make a top cover as well. Let's see how we are going to do that. 38, then the top cover comes on top, and all wires going from the back side, I guess. Yeah, something like that. So 100. So now we are going to go to midpoint again. Yes, we are going to midpoint. Oh. Something like that. So the measurement is 130 in the length. Well, when we take from the outside 5 millimeters, so that would mean that we have 120. And as you can see, because we are using midpoint reference, it looks kind of nice in the middle. Or is it? Yeah. So, and this one, it's 100 in width. So we take 100. Let's take 90. Oh, you are also designing a 3D printer. Oh, nice. I think it's quite amazing what you can do nowadays with 3D printing, what maybe 10, 15 years ago was almost nearly impossible to do. So it's, I do like 3D printing very much. And I also like to help other people with 3D printing, how to reviews, anything. But also because I'm also working full-time, I need to have a great balance between those two. Something like that. Yes. So let's make it into one shape. No. One back, one back, one back. I need to set also the height. The height from this one is 38, so we are going to make this 33. 33. And now we are going to mix them together. First align it. This box is my reference. Hello, hello. No. That box is my reference. On to there. And then also there. Oh, it's gray, so that's nice. And now we take that, and it is a nice box. Yeah, indeed, community is great. Wow. That's awesome. I need to drink something. When I'm making YouTube videos about 3D printing, I talk quite a lot. Some people do like that and some people don't. And whoa, I cannot serve both, but I added a lot of talking away. So I got three 3D printers, the CTC Prusa i3 MK2 3D printer clone, I got the Leander 3 Pro, and I got the Easy Treet X1 3D printer. Well, the last one is a very tiny 3D printer, and I was doing some preparations for an upcoming video, and I noticed that this 3D printer has on the Z-axis it was off. The calibration cube in the Z and Y-axis was quite spot on, but in the height it was 19.5. Well, I thought, okay, let's use pronto face and try to make some adjustments, but I couldn't save it. So I knew that the bootloader was not working, or there was no bootloader onto the board. And guess what I did? And it was not successful. And now a company is a little bit angry with me because why should I change a 3D printer that is made for kids? I shouldn't change anything within this 3D printer. So I'm going to make some air gaps, and to do that I've got one measurement that's 38, so I need to do something between there. So I'm going to take one hole, well, maybe make it 2, yeah, something like that. The height is also going to be 6. Yeah, if you are printing squares, cubes, you don't see it that quickly, but if you are going to make a little puzzle, it never is going to fit as well. I don't know, but Easy Treet sent me a firmware for Marlin, but there should be a Melcy board within the Marlin configuration, but I cannot do anything with it. I cannot compile it, so it's a little bit tricky. And I have some main boards which I have spare. If I'm not going to use those boards within my new design 3D printer, I think I'm going to use those boards in the Easy Treet X1. But currently it's on the top shelf, way out of sight, and currently I have 2 working 3D printers. I do need to mention that those cubes were well dialed in. So for the video for this coming Wednesday, I'm going to give some Cura slicer profiles for this, or some guides, so that people can use that for their Easy Treet X1 Kids 3D printer. With that being said, so let's get back into our own 3D printer design, shall we? And the funny thing is, I was defending Easy Treet in the past, I think 2 months ago, and it was not per definition a kid's 3D printer. I mean, a small 3D printer doesn't have to mean that it is a kid's 3D printer, you know? I think when you are talking about a 3D printer that is made for kids, then it should be easy to operate. The Easy Treet has only 4 buttons, and with a adult as supervision, you can let kids do a print on that. But you have to make sure that there is only 1 print on your SD card, or else it doesn't work. Oh, well, it does work, but then, yeah, it takes the last modified file. Six, yeah, 6. We are going for 6. Now the best part comes, the half circle. It's round roof. I usually use this to have a nice round half circle, but it doesn't work. So I'm going to take a normal cylinder, and I'm going to, this is 2, and this is also going to be 2, and 2. Oh, by the way, in which kind of software did you designed this what was it? Speaker driver? In which kind of CAD software did you use it? Oh yeah. Did you also saw the Saturn 4K resin printer? I do want to explore the whole world of 3D printing, everything, but I need to also look to my budget. So, so this is 6. This is 20. No. I took the wrong one. Yeah, 0. Something like that. Yeah. What? Oh. Yeah. I have it on midpoint. Yeah. So 0. Wow. I did design something in Fusion 360 which worked, and that was for the conversion for the Prusa i3, and it was a holder for the lead screw nut, so it fitted into the brackets for the X-axis. So it does work, but I have to make some upgrades. But I want to have my CTC working. Ooh, something happened. Hey, thanks for subscribing, Liana. Okay, we make it into a hole. Oh, this is very tiny. So, to make a copy of it. Control C, Control V. Well, we are going to select everything. We make it into a color shape so that we can see what we are doing, because this is not working properly. So first on that side. Yeah. And then, what? Why? Oh yeah, I see. 0. Goes all the way down. There. There. Deep. I do have 3 shapes. Yes. Super. Yeah. And let's make it into one. See? There we got it. So now we are going to make those vents onto the side of the printer. Well, first we are going to there. We are going to lift it up. And I want to have it on this side, because we need to have some airflow. Something like that. How many shall we make? And we are going to do it in a 45. No. First, I want to have it right in the middle. So, and so midpoint. Okay, that is nice. Add a 40. Oh. No. I'm going to take a different kind of color. Orange. Let's take orange. Something like that. Yes. So instead of using Control C to copy it, I'm going to use the duplicate function. Wait. This is the only one. Okay. Okay, that's nice. Yeah. That is what I want. So duplicate. And then duplicate. Duplicate. Oh. No. And that is how the cookie crumbles. I always had problems with making air holes or air vents, and now it's looking amazing. Oh, nice. So now I'm trying to select everything. So make it into one shape. So, and of course, because we are going to mount this part to the aluminum extrusion, I need to make some extra holes on this side so that I can just slide it right in. I still need to see how I'm going to attach the Z-axis extrusion. Oh, Fryt. I did saw something on YouTube before about Fryt. Huh. I think Fusion 360, if you learn it very well, sometimes people say that Fusion 360 is way easier than TinkerCAD. Well, TinkerCAD has basic shapes which is for me easier to use. But I think if you put some time and efforts in Fusion 360, I think you can learn quite well working with this program. And for example, I was not used to working with Excel. I thought it was just filling some cells with figures or numbers or even text. But eventually I learned how to work with Excel, and I think with Fusion 360 in the end, when you master it, when you are using it more and more, I think you have a very special tool which have endless possibilities. Also with machinery and stuff, it's amazing. So I do see that those are not aligned pretty well. I still have them selected, so I ungroup it. I will use the alignment tool, and I use this one. Now I'm grouping them together, and Ctrl C, Ctrl V, something like that. Just put it in there. Something like that. We align it. Oh, no. I think I have some spare air vents. This one I will put away. Let's see. We are going to group everything together. And let's see how it is going to look like. Yep, that's looking quite nice. I still have those under my when I ungroup them, I can those two away, something like that. Then I need to select everything again. No problem. And let's do that. There were 10 pieces, so should be 8 now. Oh, no. Okay, not everything is selected. Now it is. Everything selected. Yes, something like that. Ungroup it. No. Ungroup it. Hello. Oh, no, oh, no. Something like that. Here we go again. Yes, I did it. Then I select that one. Then I say in the middle. No. Just a second. Yeah, certainly true, Polymate. Ah, you also used Google SketchUp. Yeah, I did use it recently, but it's still need to rethink how everything works out. So this is the controller box. I still need to put some mounting holes in there, but depending on which kind of controller board I'm going to use, I can always put some screw holes in there. Well, not using a drill, but doing the proper way. For that we can use a cylinder with use a cylinder, I said, I know, listen. And there I can put a M3 or M4 screw, Allen screw in it, and then use that as a template to put everything there. shouldn't be that big of a problem, or not that difficult to do. Good that you mentioned it, because the board is located on the ground of the printer. I can use a fan on the back side. I need to make some adjustments. I can put a fan here, or I can use a fan on the back side. But I designed it on the go, something like that. Something like this. Oh, here we have our controller board. Something like that. No sitting here. Well, I also need to do something here with the wiring, because since this part is covered by the aluminum extrusions, I need to do something about that. But let's make a fan mounting plate. We have standard 40-40. How high is this? This is 38, so the fan can be mounted on the back side. Oh yeah, that's possible. So the fan itself is 40-40, so we take that as a reference. Let's see if we have a Fusion 360 40-40 fan. 40. Oh. Let's do it like this. Do I have a fan laying around? Do I have one? No. Then we are going to measurements and up. So I did see something, because eventually I want to add a very silent fan. Does it have some good reference? 92, no. Come on. Oh, which kind of fan? Okay, I was thinking for the control box, I was thinking about a 40mm fan, just a standard one that's also Creality uses for the controller box, a controller board. For the extruder with the hot hand, I don't know which kind of fan I'm going to use there. And I was thinking about a radial fan. Yeah, yeah, indeed. Yeah, this is the fan that Creality uses, but it is not that I want to have for my control board. Oh yeah, something like that. 32 plus minus 0.03. So it's 40 by 40 because of 40/40, of course. Duh. Yeah. So. This we are going to make 6. And now we are going to make some scrolls, but we are going to add some shape generator. Something I never really used before, because it has a lot of nice features. I need to Yeah, I still need to do something on the main board from the Ender 3 Pro. I always found it very messy within the controller box itself, because you have a lot of wires in front of the fan. It's ridiculous. What here? Hello. Where is the shape when you need the Thought we lay this flat like that. So it's a very busy plate. I like this. This is kind of cool. Something like that. Yeah. Copies. Take 4. Size. All object square. Triangles. Custom profile. We have circle. No, a circle. Triangles. No, also no triangles. Come on. I have to look to the right shape. Can I start over? Can I start over? Yeah. 360. I still need to work with this tool. I did see somebody use it before. That's like a sun. No? Nice. Hey. Wait. Yeah, wait a sec. Yeah, wait a second. Then we angle it like that. So I want to get this kind of moon shape. To the right way. Oh my gosh. Come on. So this shape is looking like this one. So I need to see how I get the right moon shape. So do it like this. I can also always resize it. Oh my gosh, what am I doing here? So I leave it like this. I can always adapt it if I want to. It's not going anywhere. Go on. Think big. Think big. No, no. If I do Ctrl Z, what does it do? I need to think much bigger. Yeah. Oh man. Yeah, I need to work on this. This is taking way too long. So I take this away. I put it in like that. Now I have my basic shape again. And when I do custom profile, there I don't have the shape. So circle. This goes there. This goes there. This goes there. And then I'll make it bigger. I only want to have 6 copies, something like that. Make it bigger. And the size, I think it's okay like this. I'm going to quit with this. This is taking way too long. Oh my gosh. This is 30 by 30. And it's 20 high. Oh, let's make it 6. Yeah, we are going to select that one as well. And let's say we make it into a gap. I know I still need to work on this silly little bracket for the node field to load. Oh my gosh, what? Oh my gosh, what's going to happen? So now the mounting holes for the fan. They are at 32 from each other and they have a width of 4 millimeters. Correct? Yeah, 4. Okay. So. Oh wait. That's not all the way through. I still want to continue with the S shape. I can always do that afterwards. Zero. So we take the normal shapes again. Normal shapes. Basic shapes. We take the cylinder, the 4 by 4. We need to make it a little bit wider, or not. No, we leave it like it is now. So 6. We have here midpoint. I don't see that. Use midpoint. Yes. Oh my gosh. Control-C, Control-V. There and there. First align it with okay, they are aligned. Okay, pretty nice. The gap or the midpoint between the two is 32 and rhymes as well. 32, and then I'm going to group them. Control-C, Control-V. We are going to put them in there as well. So yeah, I'm going to select the other ones and I'm aligning them. No. 32. 32 I said. So I will make it into one shape. Let's make it orange. We are going to flip this. Ooh. Oh. No. 90 degrees. We are going to lift it up. As we have it on midpoint, let's put it on endpoint, and we type in here 0, and let's add it in here. And as you can see, it is a little bit higher than the motherboard control box or the mainboard controller box, but there is also a cover coming on top of it so that you can screw it in and that you can screw it on there. So we also need to have to put some cylinders on the sides so that we can mount nuts and bolts through that. So we are also making sure that this is aligned. No, I'm not going to do that. I'm going to make it into one shape. No, not yet. That doesn't look that nice. I'm going to take this away. Little challenge here. Little challenge. 38 by 38, something like that. We put it right in the middle. Oh, we can't. If we do that, then by 40, like that. I'm going to select this part. I do it in the middle and make it into one shape. Not enough. No. Select the other one. What shape? Yep. And then we put this fan here. But then it doesn't fit. No. Okay, I need to rethink this. This is not going to work. So. No. Bye bye, cube. So this is not a great idea. I'm not going to do it like that. No. Yeah. I was thinking about it to put it there, as you could see. But then if I'm going to put a fan there, it's not going to work. And hey, I'm not an engineer, but I can see that it's not working. So, well, we are going to do a different approach. Bye. No. We are putting this little piece of art on the side. We are going to make it top cover. This was 100, and that one was 130. Am I correct? Yeah, kind of. 5. And what I can do is adding a fan on the bottom part and let the air flow out. Or shall it flow in? Okay. Designing a 3D print is much fun. And you learn something from it, right? Is the audio and video, is that okay? Catch you too later, Steve. Thank you for watching. So, what should I do? Shall I add the fan? Because I've got some other idea. Well, let's add something in there. Well, I was thinking about a fan attaching on the inner part of the cover, and then have it suck the air out and have the exhaust on the back side. So I'm going to take this as a model. Something like that. And use midpoint. So I'm selecting them both. No. Okay, I've got it right in the middle here. So if I Control-C, Control-V. Doesn't really matter. So if the fan is 40 wide, then I can look for having this fan on the back side, the exhaust. Oh no, that's not good. So this should be 30, okay, and this is going in the something like that. I don't have select more, right? Because I don't see any tree shapes. No. The distance is 50. So I need to shrink this to, those are 20, 20. How come the I-50? Strange. I take it into one shape. Then we are going to copy it. And we are going to shrink it. Something like that. It still has midpoint, of course, so I have to change that so that I can higher it up a little bit. Oh no, I don't need to. No. I select that one and I say align here and there and there, something like that. I think that looks cool. It looks nice. Make it into one shape. Looks kind of silly, but I'm not Billy. Okay, I leave it as this like that. Now I'm going to extrude this, something like that, and I'm going to flip it 90 degrees, and that's it. I'm going to flip it, boy. I think this looks way silly. Dome shape. Shall I make a dome shaped kind of fan? The fan itself, how wide is it on the inside? It's 32 maximum airflow coming up. So we are going to make a hole and hole 32, and then we are going to flatten that out. And we are going to line it right here in the middle. We are going to put that and that in the same group. We are going to align it right in the middle because it has to look pretty nice. It's flying. I think the placement of this fan duct is looking quite nice. From where are you, Polymate? No, not going to do that. Now we are going to make a little box that is going to fit over it. We have some shape that fit it. That idea. Are you working on a website? Yeah, nice, cool. And which website and which kind of thing? Your own? Oh, this is going to be challenging too. Oh. Making a fan duct. I take this round shape. Oh. Oh, the UK. Oh. Steve Fryt is also from the UK. I'm from the Netherlands, as you probably heard my accent. I still need to work quite a lot about that accent, but oh well. Oh yeah. I also want to make things for other people easier. First I learn something, and then I'm going to see if there are ways to make things easier and simpler to do. Like this ball. TinkerCAD is a different kind of ball game. I want to have here, if I can do it. What if I, yes, 32, 32, so that's my dome. And I want to that. So that's then I will say it is good. No, it's like that. It's like that. Make it into a Yeah, I also need to learn quite a lot how to pronounce certain English words. I stumble sometimes, but we all have our little things. So I like the shape, but it's no. We are going to take a half circle, half the sphere. 32. 32. Here we go again. We are going to lift it up with 4. 10, and in this case I do 5. Now I take a normal cylinder. Yeah, 32. 32. And then I'm going to add this half shape, dome, sphere. I'll put on top of it. Something like that. Now I'm going to align them. Okay. Is it that spot on? Wow. Unbelievable. Oh, no change then. Then make it to one shape. Almost look like a little cake with the pink. And then I'm going to undo the selection. I'm going to Control C, Control V, and I resize it. Uniform. I'm pressing the Shift button. I'm going to make it a little bit bigger, and I will say the shape is 32 by 32. If I want to make it 5 on each side, then it should be 40. 40 by 40. Why didn't it take the height? So this I make into a hole, and this I'm going to select. No, this and this I'm going to select. And this, and this I'm going to select. I'm going to align it in this direction and in Here we go again. 40. Then Now I'm going to align those two. Make it into one shape. Then I'm going to line it with this here. But I see that this last shape should be longer. Make it also 10. Drag those two together, make it into one shape. And go and down, all the way down. Why does it say it is purple? Pink. No, not yet. Hold your horses. And then when I select this one, no, I have to add this one too. Oh. Three shapes. Let's align them and see what happens. Of course, here. Then make it into one shape and see what happens. Little dome shape. And then I'm going to add it on top of the still doesn't fit. This looks silly. I don't want to say where it is looking like. This does look very silly, I know. But that doesn't want to turn out. No, no. Okay. Yeah, I can flip it. Thirty-two. Yes, I got it. So. All in gray color. I think it looks quite okay. Not perfect, but hey, it can do the job. What, in pink? No, I'm not going to do that in pink. No, no. Or else everybody will say that it is a kid's 3D printer. I think Lego should make a 3D printer. And what does it print? Lego bricks. I'm also going to make a little adjustment here in the near future, that it is also better printable on the 3D printer. But I think it's moving quite okay. I'm going to group it. Yeah. So that I can move it around. And if I want to make some little changes, I can always do that. I'm going to enlarge this as well. I'm going to enlarge. Well, let's put this here. I still need to do some minor things here on this part as well. Well, also on the enclosure for the controller board. I leave a gap here so that I see that there are multiple parts. Also the dummy PCB. It's oh yeah, why not using that function? Come on, the alignment tool. Oh. Align. And here's a limit to I get. Use endpoint. You know, I see that you typed colors with OU on the end, but I always thought it was color with only O. So how do you write it, in which kind of language? Because I was searching it on Google. Is it color or color? Chocolate cake. Oh man, stop teasing me. I think that looks quite nice. Yeah, that's what I thought. I didn't. But I also group them. Yeah, I'm going to group. Now I'm first going to add some length to it. I like this. I'm just putting some extra aluminum to this profile without even cutting. You ever wondered to, or you ever tried to 3D print aluminum profiles? But I'm going to do this. What? What? No. No. Then I'm going to put this here, and then I put that there. Oh. Oh, so when you are British, it's color with OU, and American English then is a color without the U. From UK. Oh, I guess. In UK they put a U in the color. Hey. So this nice piece of art. What was I thinking? Oh my gosh. Oh yeah, yeah. Resin is way smoother. I never touched it. I do the closer looks on 3D printers because I have a budget, and sorry, my bills go for buying 3D printers and 3D parts. So at this moment I have 3 working 3D printers, and well, the Ender 3 is currently the most used 3D printer with also the best quality. But I think when I'm finished with the Prusa i3 MK2 conversion, I think this printer can also get some awesome prints out of it. But first I have to fine tune this printer. Oh, I also like to play with words, you know. I'm not a language artist, but I do like to make some jokes. My wife is laughing. Oh. I did throw the ruler away. Oh my gosh. Where are we? Are we on midpoint or endpoint? Use midpoint. So we are at endpoint. So I make this into 0. Then I select this one. 0. Oh, yeah. The Ender 3 Pro is with the big Treet tech SKR Mini E3 very well dialed in. I did one calibration video, and I thought I didn't get it any better. There are 2 ways to calibrate your 3D printer. One is with the calibration cube, and the other one is the one where you are using a needle and a ruler. So based upon that, I also want to make one calibration video about that manner, because you have to exclude the material out of the equation to get well dialed calibration of your 3D printer. And for the Prusa i3 conversion, I also have to do some many dial-ins and also some other things to make this 3D printer as perfect as possible. But that is an utopia, some people will say, but getting almost perfect is good enough. I do like this profile. Where is my minus point? There's that. There's something sticking out of the bottom. So, well, let's say like we are going to use this aluminum extrusion. How long is it? This is currently 40. I still need to figure out when you have a heat bed, how long does this should be. Should I take the Ender 3 Pro as a reference point? I can do that. Wait a second. So the legs of my Ender 3 Pro are 38 centimeters, so 380 millimeters. I'm going to make this extrusion. So 380, something like that. I still don't like this extrusion. I do like that it is against it. I think Creality did. I don't know if Creality was it the one that did this thing, but I think that having your x-axis running over the z-axis frame with these v-rollers, I think that's a very nice and very rigid concept. Oh. So we are going to say minus 80. Like that. Minus 90. Oh. Minus 90. So that. Then Control C, Control V. And I'm going to use midpoint again. What just happened? And I'm going to say 170. No. Midpoint. Also not. This is how my shaping so far. What do you exactly mean, polymates? And that one. No. Hmm. Yeah, distance from that. Because this is not a circle. Oh. Something like that. This is pretty wide. So let's undo that. I'm going to make another extrusion. Ctrl C, Ctrl V. The width of the extrusion is 20 millimeters. So that is 4. So 10, 10, 15. This should be 15 long. 150. Let's I need to group this together. No, doesn't do that. Oh. No, he doesn't want. Oh my gosh. Oh. Oh. Let's group it. No. Group it. And then I say, and this just in the middle. So then I'll group it. Huh. It should never ungroup. So this together with that group, and this, and this. Looking nice. Then we are designing a power supply unit. Mine is 50. No. Huh. 90 by 110 by yeah. So the meanwhile power supply is, well, it's not very great to see. Come on, some measurements. Okay, I'm asking the wrong question. Size. So no, this is not the right one. Yeah. 117 is correct. No, not totally. Okay, 115 by 215. Yes. So 250 by 50 by 150. Okay. So 215 by 115 by 50i. So this is power supply. So the power supply, I want to put them between the brackets, the y-axis frame. So this one I'm going to group once. And I'm going to go back to 50, something like that. Take this one. So I'm going to design a bracket for this. Is it really 50 high? Yeah, it's 50. Wow. Uh-oh. Uh-oh. Oh yeah, but we also have some rails going over it, so I need to design some brackets for it, and also an on-off switch. But there is also a stepper motor coming there. So I'm going to select this one, this, and this, and this. Shall we make that 50? No. We are going to make that 50. Something like that, and we are going to change the color to that one. Control C, Control V. This is just for the idea how it is going to look like. I'm going to work on this one in another live stream, I guess. Yeah, I think that looks quite nice. Now, so 8 by 8 by so I need to move this rod, this smooth rod, with 260. Oh, 288. 7. I think this looks quite nice, and it's also time for me to quit with this live stream. So I'm going to save this Z3DP and K1. The Z3D prints Z3D PMK1. Yeah, I totally agree with you, because I didn't thought that I would get this far in the process. I think it's looking okay, and yeah, it's just in 3D, so I still need to work everything out. I need to order the parts. I do have some spare boards which I can use. I still need to order some other things like the power supply unit, a stepper motor. So yeah, nice talking to you too, Polymate. It's very nice. I did a other live stream in the past with the unboxing and first impressions from the Easy Treet X1. It didn't turn out that well, also because of the lower subscriber count. Also the first time that I was doing a live stream, and I think that this one turned out quite well, and I'm very happy with everybody that came, who viewed my videos. And if you watch this live stream in a later stage, then feel free to subscribe to my channel, Zachary 3D Prints. I upload every Wednesday and Friday new videos. On the Friday is a special, this Zachary 3D Prints news and updates. Usually in those kind of videos I take closer looks on new to be released 3D printers, with sometimes an exception like the longer LK4 Pro, which I always thought that it was a clone of the Ender 3 Pro. But after a closer look, it turned out that it is quite awesome 3D printer. Yeah, I did look to the 3D Maker Noob. I watched one of his first videos, and I was amazed that after just 3 months that he was at the 1,000 subscriber count. Almost having a YouTube channel for almost a year, and he didn't even touch the 1,000 subscriber count. But I did see that he was going over the 5,000 subscriber count within a year, and I saw that he was doing a lot of live streams. I'm not sure. I'm just guessing. But everybody has his own path on YouTube, on social media, and I think for a 41-year-old guy who just discovered 3D printing 2.5 years ago, I think this is quite nice to have. The planning is to get more into the 3D printing on YouTube, to also meet other peoples and have an awesome time on YouTube with some other people in the 3D making scene, 3D printer scene. So I'm going to close this video capture device. So, I know, something like that. So, everybody who joined the live stream, once again, thank you very much for the support. If you didn't subscribe to my channel yet, please consider subscribing, hit the notification button to get the latest information and the latest videos right into your mailbox. And you can follow me on Instagram, Twitter and Facebook. I have a Facebook page, Zachary 3D Prints, and there you can also find many things I share on the social media. Yeah, it's which kind of niche is that? Yeah, I'm also going to look for your YouTube channel and definitely going to hit the subscribe button. Hey, that is it. I'm going to close also this live stream. Everybody, thanks for watching, and I will see you next time. And hey, let's make some fun with 3D printing. Zachary 3D Prints. Bye bye.